Hello class, I hope you're having a wonderful day. Today I would like to introduce Chapter 2, Representing Motion, and I would like to go over a few things. Let's first talk about the difference between a scalar and a vector, and then I would like to discuss the difference between distance and displacement. So, scalar, these are quantities that have numbers only. I'm going to add, they do not include a direction. Now, a vector is a quantity that has both magnitude and direction. And I want to add here that a vector can be represented by arrows. Okay, and we're going to talk about some examples here in a minute. But the next thing I want to talk about is the difference between distance and displacement. So distance is the total length traveled to reach a destination. Okay, and we have an equation to represent distance. It is d subtotal. And when I say sub, what I'm referring to is a subscript. So d represents distance with the subscript total. So d subtotal equals d1 plus d2 plus dot dot plus d sub n. Now, n over here, the n subscript, means that however many distances you have, you're going to add all of those distances together to come up with your total distance. Okay? Now, displacement is the change in position with respect to the origin. Now, I also want to add here that it must include a direction because displacement is a vector while distance is just a scalar. So let's add on displacement. It must include direction because it is a vector. Okay? And so you might say, well, okay, one is a scalar and one is a vector. But is there any difference between the numerical value? Well, sometimes there is. And so what I'd like to do is go over a quick example. Okay? And we can just use an example of a student going throughout the day, following the student throughout the day. So, I don't know, let's think about Micah, and we'll follow him after he leaves Moore Norman going to lunch. So, for example, Micah today will start out at Moore Norman Technology Center, okay? He's going to leave. He'll travel north 2.5 miles. He'll pick up his girlfriend. Okay? So, girlfriend. Okay, and he's traveled 2.5 miles north. Okay? Well, he wants to take his girlfriend to lunch. we'll say he goes to Outback Steakhouse, okay? So he travels another 2.5 miles, okay? To go to Outback Steakhouse, have a nice lunch with his lady friend. Well, he's a little bit tired of the vehicle he's driving now, so he's going to go to the Porsche dealership. And he's going to pick himself up one of those new Porsche 911s, okay? So Porsche, and he buys the new 911 Turbo. Because we don't want a slow one, right? No, huh? We want the good one. And let's just say he travels 10 miles north to the Porsche dealership. Well, after he picks up this nice new Porsche, he wants to have some fun, and he says, well, I know a huge pool party that's going on. So he travels 10 miles to this massive pool party. Okay? Now, after he's at the pool party for a while, some of his buddies are like, hey, I want to take a ride in your new Porsche. Okay? Well, he decides, okay, I'll take you guys home. So, he goes 10 miles south to his friend's house. Okay? Alright, so he drops his friends off, he hangs out with them for a while, and then Mike is like, hey, before I go home, I need to make one more stop today. Well, we all know what that stop is. That's going to be girlfriend number 2's house. And let's say that is 5 miles south. Okay? So, we followed Micah after lunch today, and we want to calculate his total distance traveled and the displacement from Moore Norman Technology Center. So the question is, could these values be different? Well, let's see. What we're going to do is use the base equation for total distance. Remember, d sub total is equal to d sub 1 plus d sub 2 plus dot dot plus d sub n. Remember, the n subscript here represents all of the distances, all of the total lengths traveled from the starting point. So, distance 1. So if we have 15 different distances, what we have is d sub 1 plus d sub 2 plus d sub 3 all the way through d sub 15, okay? So what let's do is let's sum these values right here. Now just put them in parentheses to separate. So distance 1 is 2.5 miles. Distance 2 is 2.5 miles. Plus distance 3 is 10 miles. Plus distance 4, 10 miles. Plus distance 5, when he leaves the pool party and goes to his buddy's house, this is 10 miles. And then the final distance he travels from his friend's house and he goes and visits girlfriend number 2, he travels 5 miles. Okay, so what we've done, we have set up the total distance equation. So d subtotal right here, we have, it looks like 40 miles. Okay, so 30, 35, 40, yes. Okay, now remember that distance is a scalar. It does not include direction. We just have magnitude, okay? So this is a scalar value because we are not describing the direction in addition to the magnitude. So total distance, 40 miles. Now, let's take a look at Micah's displacement here, and let's see if it's any different. So, all right, over here, displacement is identified by delta x, and our Greek letter delta here represents change in. So the change in x, this is position, we have x sub f minus x sub I, where x sub f represents the final position of our object, minus x sub I, the initial position of our object. So what we have here, we know that this distance is 10 miles, okay? So our final position is 10 miles away with respect to Moore Norman Technology Center. So 10 miles minus, well, our initial position, 0 miles. So delta x equals 10 miles. And since it's a vector, we must include direction, and we are to the east. Okay? And so when we start doing more practice problems here, we're going to run into many situations where instead of saying east, we can use something like a vector arrow in many cases. Now we must include the arrowhead pointing in the correct direction. We can say positive x direction, okay? Something like that. So we're going to have many different scenarios where we can use different descriptions to describe our direction, okay? So if you have any questions over the difference between a scalar and a vector, or the difference between distance and displacement, please send me an email. I hope you have a great day.